The vessel pictured here is the HWSB Skim Tank, and its externally adjustable water leg. It was developed by Bill Ball, president of Breakthrough Ingenuity. The HWSB is used to improve water quality, and to capture all recoverable oil. It is a replacement for oilfield gun barrel tanks, which work when the inlet fluid is mostly oil, but perform poorly when water volumes are high. In contrast, the HWSB works best when the inlet fluid is mostly water, with 1% oil or less. 1% oil is 10,000 ppm. Clarified water leaving an HWSB has less than 50 ppm oil. HWSB recovered oil can range from 10 to 300 barrels per day, paying for an HWSB in a matter of weeks. Oil is normally pipeline quality, and ready to sell. Clarified water is suitable for frac reuse, deep well water injection, or disposal. Let's see how the HWSB works, using this 3D model. The inlet water stream has normally been degassed before reaching the HWSB. When this is the case, the water enters through the side of the tank, and into its vertical center column on tangent. This tangential connection creates a centrifugal force that throws heavier sand and solids outward, while lighter oil flows up the middle of the center column pipe. At the same time, the solids fall downward and collect on top of a solids baffle, so operators can drain them off. The liquids spin upward in a counterclockwise spiral inside the center column pipe until they reach exit slots. Any gas evolving from the inlet stream rises past these slots and exits into the gas layer at the top of the skim tank. The center column exit slots are located a few inches below the oil layer and just above the upper umbrella baffle, so separated oil only travels a few inches to enter the nearby oil layer above. The center column exit slots are fitted with deflection fins on top of the baffle. These create counterclockwise fluid rotation, which results in a helical flow path that reduces the water velocity and adds retention time. The added retention time encourages oil droplets to separate into the nearby oil layer above. The separated oil spills over into a clean oil outlet compartment near the top of the tank. When an emulsion layer accumulates below the oil layer, it is removed through 3 special interface draw-offs located in the emulsion layer below the oil. All 3 are connected so operators can drain the emulsion off through a single valve. The HWSB clarifies water by separating nearly all oil droplets. It does this by slowing the water down, which increases residence time and allows the smallest oil droplets to coalesce and separate. It starts with a helical water flow path as water exits the center column. As the length of the helix increases, water velocity decreases. As the water reaches the area past the outer edge of the upper umbrella baffle, it changes directions and rotates downward to flow between the baffle and the tank walls. Many larger droplets do not make this transition. Some impact the tank sidewall and wick up, while others simply flow upward and into the oil layer above. The remaining oil droplets flow down with the water, through the space between the umbrella baffle and the tank sidewalls. They are the smallest and most difficult to separate, until the water slows down even more. As the water reaches the bottom edge of the large upper umbrella baffle, an eddy is created that pulls the water underneath the upper spreader baffle, and forces it to redistribute throughout the entire tank. This slows all downward water flow, so the remaining oil droplets can rise upward through it. As the rising oil droplets reach the underside of the upper umbrella baffle, they collect and migrate up through a dedicated oil pipe and into the oil layer above. The water continues to flow downward. When it reaches the lower umbrella baffle, it converges to flow through the annular area created by the baffle and the tank walls. For the clarified water to leave the skim tank, it must flow around the outer edge of the lower baffle, then turn upward and flow along its underside. The underside surface collects and coalesces remnant oil, which then wicks into the center column through small weep holes. It accumulates under the solids baffle and flows through 2 weep holes in the center column. Once outside the center column, these larger oil droplets rise until they reach the underside of the upper umbrella baffle, where they concentrate and flow into the oil layer above. The clarified water flows along the underside of the lower umbrella baffle and through 4 metering holes in the center column, designed to assure uniform water flow. Water turns down and into the center column until it reaches the water outlet piping leading to an engineered water leg. The water leg design incorporates two concentric pipes, one inside the other. Inlet water flows up the annulus between the two and overflows into the inside pipe. An adjustable slip sleeve at the top of the inside pipe is operated by a manual jack screw mechanism outside and on top of the water leg. It adjusts up and down to raise or lower the water spillover elevation of the inside pipe, which simultaneously raises or lowers the water oil interface inside the HWSB. The jack screw gives the operator an easy way to adjust the depth of the oil layer inside the HWSB, without ever having to pause or stop the HWSB operation. To summarize, the HWSB is the industry's only true oilfield skim tank. Its initials stand for the industry's only hydrodynamic water separation breakthrough, and it has become a standard of the upstream oil industry. Over 5,000 HWSBs are currently in service worldwide. The HWSB design is protected by several active patents and is offered for sale by KDK Industries.